Now that you know a bit about the structured functionality, let's talk about the key methods that are defined in the cyclic barrier interface. This also has a very simple API. There's only a handful of methods that are commonly used. There's a few other methods that could be used in more specialized purposes, but there's really just a couple that are used in practice. The constructor initializes the object to trip, to let people continue, when a given number of parties have shown up to wait on it. You can see here that we've got a couple of cyclic barrier constructors, and here parties, which is the sort of the count of the number of things that'll be waiting, they really equal threads. So when we hear party, just think the number of threads. Whoops, that's spelled wrong. Cyclic barrier requires a fixed number of threads that's identical to the number of parties. You can also provide a barrier action optionally. You can not provide one at all, but if you provide one, when the barrier is actually tripped, in other words, when the last party shows up, then the barrier action is automatically dispatched. And that can do some kind of initialization to, reinitialization typically. And it's always performed by the last thread to enter the barrier. So the last thing that comes in and calls a wait is the one that will trigger or trip the cyclic barrier. And if there is a barrier action provided, then that's where that'll be dispatched. And it's a runnable, so its run hook method will get called back. When the run hook method of the barrier action is dispatched, all the threads are suspended. So you don't have to worry about race conditions because they'll all be paused or suspended to allow this reinitialization to take place, or this reassessment to take place. Barrier actions are typically used to update any mutable state before any of the parties continue on with their processing. So as we'll see when we look at the example, we might use that to reinitialize the data structures that will be used for the next phase of the cyclic barrier. The barrier's count is automatically reset to the initial number of parties after the barrier is tripped. So remember, we have two things. We have the total parties field and we have the count field. Initially, count is set to total parties. Every time someone awaits, we decrement the count by 1. And when the count hits 0, that's where things get tripped. The barrier action's called, and then all the threads, if you haven't decided to shut things down, can start to run again. There's a couple of key methods. There's await, and this is really the main method, await. And so it basically is used to block until all the parties have shown up. So you can't continue until everybody's there. And then it'll automatically reset the count back to the number of parties after things are tripped. The threads that call await are given the option of deciding whether to continue for the next cycle or not. So this version of await blocks until all the parties arrive, the barrier resets, or the thread is interrupted. It returns the arrival index of the thread at the barrier. So it basically, every time you call await, it'll give you back the count that indicates what you were. If you get back the value from await, which is 0, that meant that triggered the tripping of the cyclic barrier. So you could use await equals 0 as an indication that the barrier had been tripped if you don't need to suspend all the threads. If you do need the threads to be suspended for some reason, then you're better off using a barrier action because that'll run with the thread suspended. This will not run with the thread suspended, but just as an indication that we were the last one who came in. This version of await will block until all the parties arrive, the barrier resets, the thread is interrupted, or the timeout elapses. So you got a timeout here in time unit. I believe, I'd have to go back and look, but I think also with cyclic barrier, you can't have uninterruptible awaits. It's also possible to manually reset the barrier to its initial state. So again, if the count was 4 and you call reset, whatever the count was, it'll let all the threads go and it'll reset the count back to the original number of parties. Any parties that are waiting at the barrier at this point will be released, but they'll be released with an exception rather than the normal return. The normal action is just for await to go on to the next thing after it. But if the barriers reset, that causes a broken barrier exception to be thrown rather than just the normal return. So you would have to be prepared to catch the broken barrier exception. And that's actually a somewhat goofy thing with cyclic barriers. You have to write try-catch blocks and so on in order to handle them properly. Okay, so that's a quick overview of cyclic barriers.